Good morning everyone. Welcome to the forum under the Professional Engineering course MMJ 40102. Our group is the FOURMATICS. My name is HRV and I will be the moderator. And there will be 4 panels, which is first Roshan, Chandra Kumar, Somesh and Muhammad Anas. Today we are here to discuss our project, which is the development of energy-savvy heat recovery ventilation HRV unit, which we designed to enhance energy efficiency while maintaining healthy indoor air quality. The focus of our forum is to reflect on how we apply sustainable engineering principles, ethical responsibility, and professional value throughout this project. We will be exploring key areas such as the motivation and problem statement behind our HRV unit design, how sustainability and life cycle thinking we are embedded, the ethical and legal consideration we followed, how we manage value conflicts, and finally, our awareness of project environmental and community impact. Let's begin with Roshan, who will explain the core problem statement and objective that guide our design.
Thank you, Shafi. Basically, the problem we aim here in our project, we are going to solve is the energy penalty that occurs when modern airtight buildings use conventional ventilation system. The existing traditional exhaust fans or open windows remove conditioned air and bring in hot or humid air from outside. This forces the heating ventilation air conditioning or HVAC system to work more harder, which consumes more electricity as well as increase the carbon emission. Our HRV unit that we are designing will tackle this issue by recovering the heat from the exhaust air and transferring it to the incoming fresh air. This will effectively reduce the load on the HVAC system. We emphasize on 3 main objectives in our project. The first objective is to achieve at least 75% heat recovery efficiency. The second is to ensure compliance with nation legal and safety standards. And the third objective is to internalize sustainable and ethical design practices throughout the project. We also use the 5-way analysis method to identify the root cause of energy inefficiency and justify our product selection. The HRV unit we are designing emerged as the most holistic solution because it directly balances 2 competing priorities, which are indoor air quality and energy conservation. Through this approach, we address both engineering performance and sustainability impact, aligning our design with the global shift towards green buildings and low carbon technologies. Thank you.
Now let's pass to Chandra Kumar.
Thank you, Mr. Ravi. I would like to talk about sustainability and life cycle analysis. From a sustainability standpoint, we applied a cradle to grave life cycle assessment to the HRV unit. This analysis covers every phase from material extraction, manufacturing, distribution, and use up to end of life management. In the raw material phase, we emphasized to the use of recyclable aluminum instead of polymer. This reduces waste and aligns with the circular economic principles. During manufacturing, we focus on minimizing energy use and eliminating volatile organic compounds in the paints and adhesives. This phase is the most critical. It is where the HRV delivers its main sustainability benefit by recovering up to 90% of exhaust air heat. It lowers the building energy requirement, directly cutting down carbon dioxide emissions and operational costs. We also designed the HRV for disassembly, making it easy to recycle and repair components at the end of its life. Our analysis aligned with three pillars of sustainability. First, environmental. It's reduced energy demand and recyclable design. Second, economic. Long-term savings for users to lower electricity consumption. Third, social. It's improve indoor air quality, contributing to health and comfort. Altogether, these elements ensure that our HR system supports SDG 3, good health and well-being, and SDG 7, affordable and clean energy. Thank you.
Now we give some space to soulmates.
Okay. Let me building on what our panel Chandra Kumar said. Ethics and legal responsibility were at our heart of engineering decisions. According to the Board of Engineering Malaysia, which is also known as BEM, Code of Professional Conduct, we must prioritize public safety, environment sustainability, and also integrity in every aspect of our work. For example, we had decision between using cheap polymer materials such as steel and etc., and also recyclable aluminium. And what we choose was aluminium. You know why? Because it is still, even though it's more cost more than normal steel and so on, we use aluminium because it's better quality and it won't rust and won't injure our customers or consumers.
Yes.
So, and legally, we made sure our design comply with several key Malaysian laws, which is I'll be using three main ones, which is the Environmental Quality Act 1974, which is also known as EQA, ensuring our design minimize pollution. Second one is the Occupational Safety and Health Act 1994, also known as OSHA, protecting both users and workers. And finally, Factories and Machinery Act 1967, also known as FMA, which governs machinery safety and maintenance. This framework guides us in making responsible decisions, ensuring that HRV unit is safe, lawful, and environmentally responsible. Our reflection also strengthened our understanding that engineers are accountable for the consequences of their designs, both legally and morally. This mindset will continue to shape our approach as a future professional engineers.
Thank you, Sumesh. Now let's hear from Anna's side.
Thank you, Sherry. In our project, one of the key aspects was prioritizing sustainability values and managing conflicts effectively. We developed a value ranking system to guide our decision. The first one is health and safety, environmental protection, and also affordability. This ranking helps us balance competing factors such as cost, sustainability, and performance. For instance, when the cost of sustainable materials like aluminium was higher, we assessed the life cycle benefit and found that the long-term environmental savings outweigh the short-term financial costs. Our decision-making process was democratic and evidence-based, where every team member contributed to discussion on trade-off between performance, noise level, and recyclability. By managing this conflict, we ensured that our design not only met technical standards but also reflect responsible engineering judgment. This process enhanced our teamwork, leadership, and professional awareness, preparing us for future roles where engineering decisions impact both people and the planet. Thank you.
Furthermore, I would like to add on some point on the community and environmental impact of our project HRV unit.
Sure, can.
Basically, this HRV unit offers substantial community and environmental benefits. Environmentally, it reduces the buildings of carbon footprint by cutting down the heating and cooling energy consumption. This directly supports the nation's effort to transition to low carbon development. Socially, it enhances the indoor air quality by continuously providing fresh, filtered air and removing all the pollutants such as carbon dioxide, volatile organic compounds, and allergens. This helps and makes sure that the consumers does not get any respiratory illness and improve occupant well-being. As our panel said just now, it aligns with the SDG good health and well-being. However, we also acknowledge the implementation challenges such as high initial costs for developing this project and setting up and limited public awareness. Therefore, we recommend some government incentives, public education, and technician training program to encourage the adoption of this project into this role. In the overall context, this HRV unit contributes to both healthier communities as well as a cleaner environment, aligning with United Nations Sustainable Development Goals. Thank you.
That's a very impressive point for Roshan. Thank you, Roshan. Now we are heading to the end of our session. To conclude our discussion, I would like each of you to share a brief personal reflection on what we have learned throughout this project.
If you ask me, Mr. Shawi, I would like to say I learned the importance of analyzing a product full life cycle and how sustainable design requires long-term thinking beyond just performance. That's it from me.
I completely agree with Mr. Chandrakumar. But for me personally, it's about understanding engineering ethics. That every material or design decision must serve public safety and environmental responsibility. That's all.
Okay, from me, I developed a deeper appreciation for team collaboration and how ethical discussion shape the outcome of sustainable project. That's all from me.
I would agree with the ideas of all these panels, but from my side, this project strengthened my sense of professional accountability, which balanced this innovation with legal as well as the moral responsibility.
Thank you everyone for your comments. To summarize, our energy saving heat recovery ventilation unit project demonstrates that sustainable engineering is not just a technology, it's about our responsibility. We successfully applied the 3 pillars of sustainability compared with BM ethical code and Malaysian laws, and designed a system that improves energy efficiency while maintaining human comfort and health. Through this project, the FOURMATICS have grown as future engineers, not only technical expertise, but in ethical awareness, teamwork, and sustainable thinking. We believe the HRV unit stands as a model of responsible innovation, contributing to Malaysia's sustainable future and the well-being of our communities. We hope this forum reflects some good knowledge to everyone. Thank you and have a nice day.
Thank you, Mr. Dewi.
Thanks.
Thank you, Mr. Erwin.